Okay, now we're going to duplicate this command, this routine, so that we can cut the fillets on the outside of the hex, or I'm sorry, octagon. Okay, so we're going to be changing the default settings because it's a different kind of feature. These are exterior, so that's going to be considered a floor, and the facets are going to be considered walls. A little convoluted, but that's how the command works. Makes a little more sense when the walls create an internal cavity as opposed to an external shape. Okay, so we got our floor. We're going to select each of the fillets that crown the top of the part. You got to make sure you get all of them, including those little ball rollover fillets. If you don't, you might gouge there. Or it might just avoid it and leave a little bump. Take your time. I believe there's 16 of them. That would be 8 times 2. Okay, and then our wall surfaces are going to be the flats plus the fillets. Now, think of it as something that the cutter could run into that you don't want it to. We're cutting one set of fillets and we're avoiding the other ones that are already established by another cutter. And I believe what we're going to do is we'll also include the top of the part as a wall. Okay, we want to make sure that we've got our faces set, it looks correct. And then down here at the bottom, we've got our stock to leave. You know, we could leave material on a floor or wall, but this is an external feature, so I think any clearance we put on there would interfere with the fillet. We're going to keep default planes. Our step over is going to stay the same as it was. We're going to go up to 110 on the maximum angle. That was the default because we're on an exterior feature. I think we'll be okay there. And under linking, I believe we're going to leave everything at default and select OK. Okay, so this command's a little funky with the first cut. For some reason, I think it's because of the fillets that go to 0 in the corners. It doesn't know how to wrap from one to the other. So you see you have this lead in for each one. So it's going to start off with 8 linear moves, and it retracts for each one of those. There's probably parameters we can tweak to get rid of that, but for this, it's going to come out okay. Now, we want to simulate this, because we want to see if it's doing what we think it's going to do. Okay, so it's doing one conventional cut, another conventional cut, and it's going around. So I believe because our walls are really inverted and falling away, it's gotten confused on what is climb cut or what side of the material it's on. And now it climb cuts in a octagonal shape. So I don't like that. The surface is going to be a better finish if we climb cut. So as soon as this stops, we're going to go back in and we're going to change the direction of cut. Okay, we're going to exit the simulation. We're going to edit this routine. We're going to go to the fourth tab, which is passes, and we're going to change climb to conventional. There may be another way to change the direction, but this seemed to work. So going to conventional, it's truly going to be climb cutting. Hit OK. Remember, on a CNC machine, you want to climb cut with everything but saws. Okay, there we go. It's regenerated. And if we simulate it, we can make sure it's going in the direction we want it to go in. I wouldn't say correct direction, but Okay, so now our moves are still one at a time at the beginning. We got 8 moves, but at least they're moving in a direction that the cutter is climbing against the material in its rotation. And then it skitters around going clockwise. I don't know if it's me, but it almost looks like it's going faster doing it this way. Or maybe it's just cached. Okay, now what we're going to do is we're going to copy that routine and do the fillets on the lower half of the chamfer with the same cutter. All right, so we're going to use the same feeds and speeds, and we're going to go to the next tab. We just have to select different items. So the first one is we're going to remove the top of the part because the next fillet doesn't touch it. And then the features we're actually cutting are going to move. So we need to reselect those. Again, make sure you get every single one. Should be 16 of them. Okay. Now we're going to select our walls, which the one set of features are common, but now we need to select a different set of walls. It's basically the faces that are tangent to the feature we're actually cutting. There's multi-select methods for this, but I don't know. Maybe I'm old school, like to count them. So we should have twice as many walls this time with 32. Okay. I'm going to select OK, keep everything else at default, and see what happens. Okay, remember this one we set for conventional cutting too, so it should, it enters and then it goes around in a circle. This one doesn't do those individual cuts, so maybe it has to do with the angle. You know, the top being first cuts being normal to the standard spindle direction. All right, it looks like it rolled over the sides just fine. We're going to go to simulate. Okay, done with the facets, done with the fillets. Okay, now we're going to deal with the features on the side. Now here's where things get more interesting as far as 5-axis. These features could be done on a 4th axis. It's kind of debatable on whether this part lends itself more to 5-axis versus 4. You're definitely going to save some time with using 4-axis to hit all these features that go around in 8 places. This could be all machine though, and multiple ops and a vise. So remember, when you're planning these jobs, if you're not reducing the number of setups by going to a higher axis machine, you are not being efficient. Okay, so what we're going to do first is we're going to do spot drilling. And I realize that Sierra College does not have a spot drill in its standard library, so we are going to cheat, and we're going to use the chamfer mill. I don't actually recommend doing this a lot, but in aluminum it's all right. And they might not be so great for engraving when we're done here, but the bit will make the proper angle we want. So the goal is to make the chamfer that first spots the hole, and then it helps the next drill bit go in, but it also creates the edge chamfer before the hole goes in, and you get less burring. Okay. So we got this little lead-in chamfer that's 90 degrees. We're going to run at 4,000 RPM. I don't want to burn this thing up. And we're going to go actually a little slower on our feed because this thing's not really designed to do what we're doing with it. Okay, we're going to go to geometry. Okay, and what we need to do first is select our tool orientation. This is really important. Okay, so first we're going to select the face of the that's normal to the hole we're going to machine on. So this will put the command in to rotate. Okay, so now the Z flips towards the plane we just selected, and we need to make sure the X-axis is pointed to the right, which would be pointing to the A-axis of the rotary. It looks like it already is, but I'm going to go ahead and select the line, and now it looks like we got to flip axis to get it going in the correct direction. If you get confused, turn on the model of the machine and you'll see where the part is in relationship to it. Okay, so that's set up. Our axis nose in the right place, and then we're going to select our hole feature, which is going to be the chamfer lead in. Okay, and it looks like it picked up the top and bottom of the hole, so it looks like it's going the correct depth by default. Okay, we're going to go to heights. Just going to check everything. I'm going to leave pretty much, I guess, yeah, if we're doing 4-axis, it wouldn't hurt to have extra clearance. A lot of times I will go to model top if I know the hole is on a machine finish. But it looks like our depth is correct with the default settings of hole top and hole bottom. Okay, so we're going to go to the next tab, and that's the drilling cycle is going to call out. We're going to do what they call the deep drilling cycle. It outputs a G code that does a retract, and that works well for aluminum because it tends to be a little sticky, and when it retracts, it throws a chip off. We're going to go 60,000 steps. And because this is a 2-flute chamfer mill, we're going to actually put a dwell in so it pauses. Make sure that we get a nice chamfer finish. And we're just going to have it dwell 1 second. Okay, and there we go. We've got our first, what I would call 3+4 move. I'm sorry, 3+1 move. It's a 4-axis indexing move. Okay. Wow, it looks polished, that rendering. All right. It looks round, but it's really not. Just the rendering. Should be a cone shape. I'm going to exit the simulation. All right. Now what do we do next? Okay, we want to do this same feature so we're not changing tools over and over. We're going to have the part rotate and go to the next location. So I had the part rotating in this view, facing it clockwise, okay? But it's basically going to rotate so that the hole is normal to the spindle. So we duplicate the toolpath so we can use all the settings we already did. And we're going to hit edit. And there's only a few things we have to change. First one is you definitely have to index the rotary, and you have to pick the different hole face. So we're going to do Z-axis plane and X-axis. Instead of the face we just did, we're going to move on to the next one. on the left, which rotates our piece clockwise, and the edge should be the front edge of the part. Looks like it's flipped the wrong way. It should be pointing to our right. So we select that, and that looks like the proper orientation. Z in orientation to the spindle, and X to the right. Should be in line with the A axis. And then we select the different hole and hit OK. There we go. That's all we got to do do this. This is a good time to pause the video. I'm not going to have you watch me do all 8 of them. So you will do the following 6 and then restart the video after that. Okay. So you position it like I've got there. And you notice I'm going to rename all these. So welcome back. You should have all 8 of these done before you proceed beyond this point in the video. We're going to simulate the entire part up to this point to see what we've done so far. So we milled the top, cut our pocket, cut our octagon, cut our swarf for the chamfer roughing, then a finishing cut. Then we do a 5-axis finishing move to cut the fillet. When that's done, it's going to go around the top of the octagon. It's starting to cut the exterior fillet. And the goal of the swarf cut is to not actually have the center of the cutter cutting material. It's trying to avoid that. Okay, now our drilling cycle goes around and hits all 8 sides. Okay, so you kind of see what's done so far. The rest of the drilling, we probably won't simulate it to this level. The simulating in hexes will go in those same locations, so the similar process. I do suggest you update the name so you know what the operation's doing. It puts notes in the program for the operator, and so you gotta exit simulation first. But so we're going to change these, even though it's not a spot face tool, it is doing a spot face function. So I went and changed all those as spot drill 1, 2, 3, 4 through 8. Just good practice in house cleaning. Or you might describe what the feature is. Gives the operator a chance to understand what's next. Okay, there we go. All right, now